whatever we discuss, these are your personal views. You're not representing any organization in any way,
Yeah,
right?
totally.
So,
That's
yeah, I would
important.
like to start with a very, I mean, the same question around fitness. Honestly, it's not related to tech, but I have usually heard a lot of stereotype about highly intelligent people not being that strong in terms of their physical fitness. Have you ever had to deal with people making assumptions about your brain power just because you look like you can bench press a truck?
Not people whose opinion I would care about. Like it happens
Right.
sometimes. Like it'll be like online arguments, and somebody will be like, "Who does this idiot meathead think?" Like they'll literally say that. But who does this idiot
Yeah.
meathead think he is to have an opinion about this? I'm like, okay, dude. I mean that, like that actually shows how shallow intellectually they are because
Yeah.
there is a thing. What they should be thinking is really the opposite. The
Exactly.
the author Nassim Taleb, if you heard about him, he's pretty famous because of the Black Swan idea. He talks about this in his books. He says that if you go to a surgeon, right, and then there's one surgeon that looks all polished with great hair, slick back, and just the whole 9 yards in terms of looking like a surgeon, and another one that looks has sausage fingers and looks like a butcher and is scruffy, that you should
Yeah.
probably, and they both have equal job titles, you should probably go with the butcher looking one because he had to overcome those biases to get there. So he's probably better. The first one, the guy that looks the part, has a halo effect to him. So
Yeah.
he may not be that good. And so like the correct way to think about it is the opposite way. And people who are intellectually deeper understand this. So it doesn't really hold you back in any way.
Makes sense. Yeah. Yeah. I mean, I feel in some way it does help you a lot when you do some sort of physical activity. It helps you a lot in focus as well,
Oh yeah.
which will eventually help a lot in your day job.
Yeah.
So I think it makes a positive impact as opposed to a negative one.
Yeah, absolutely. Like your ability to do hard things is a general skill that you can
Yeah.
train by many mechanisms, but one of them is, fitness and getting under heavy loads and putting your body through heavy strain is for
Right.
sure something that builds resilience in a generalized sense.
Awesome. Got it. My next set of questions are around the posts and blogs that you have written, recent ones. You recently posted about gurus bragging about pushing 50,000 lines of code per day using AI. I mean, calling those 100 times productivity claims laughable, which I agree with. In a massive enterprise system like AWS, why is focusing on lines of code completely missing the point of what a senior engineer actually does?
Yeah, there's a lot of reasons, but the main thing that article tried to do is like even if you did focus on lines of code,
Hmm.
you're going to hit a bottleneck very soon, which is let's say that you are able to accelerate, to thousands of lines of code per day, and you're able to build automations that make it so that you don't have to review most of it. What's going to happen is that your release trains are going to get huge. So every
Hmm.
time, normally under normal conditions, you make a code change, you commit, and it goes through your pipeline, it goes through your CI pipeline. One or two commits might get released to production. But if you
Right.
accelerate that much and it's 100 commits that get to production, then whatever your defect rate is, and by defect rate, it's very important to understand that it's not just bugs, it's not just logic bugs, it's also performance bugs. It's also,
Hmm.
like a query that's not properly indexed, just high latency, that type of thing. Your defect rate is what it is. If you're shipping a production release with 100 changes, then that defect rate compounds on itself. And if the defect rate was 10%, then with 100 changes, it's going to be very high. It's almost unlikely that it's almost impossible that out of 100 changes, none of them have a defect rate if the defect rate is 10%. So that's the main thesis of that article. Like you can accelerate code all you want, and you can accelerate code reviews all you want, but the bottleneck is your pipeline and your ability to detect issues. So if you only are able to detect issues when you go to production and you see metrics, then your pipeline is going to be at a standstill pretty soon. So that speed increase, you're going to be able to measure it for 2, 3 weeks, a month tops. And then you're going to be at a standstill and you're going to be you're going to put your team into a very bad situation with a lot of stress that they have to now fight their way and claw their way out of while still trying to deliver on the things that they promised they were going to deliver. So it's just a bad situation all around, you know? So that's the thesis of the article, but there's many other reasons. Like lines of code themselves are not an asset. Code is a liability. Like the more code you write to solve the same problem, the worse it is. The more of a maintenance nightmare it is. The more dependencies you have, the more logic you have to maintain. Like it's all bad. Like this whole thing about, bragging about how many PRs I do a day, how many lines of code I write a day. It's a marketing collateral. It's something that people who benefits from you using AI put out there as marketing. It's just marketing. That's all it is. And people are believing it as if it was true. And you'll notice that it's just marketing because they never go deep. They never show how much money they're making, what features they built with all those lines of code. And they talk about things, they make up terms, like loop engineering. It's nothing new. Like it's just a cron job that wakes up the agent and checks a queue. Like what is that? Like there's nothing to that. There's no magic there, but they don't go into that level of detail because they're not actually interested in you learning. They're only interested in creating that FOMO and going viral. And then in the comment section, they'll say something big like that. And then in the comment section, you'll have the glazers loving what they're saying. And then the other people, the haters coming in and fighting the glazers, and then back and forth, back and forth, back and forth. And that's the activity that they want. They're just trying to get famous. That's all it is. And a lot of the discourse in AI is people just trying to get famous. And we as engineers need to understand this and need to be selective about who we listen to.
Correct. I have an additional question to that, actually. As you mentioned, these massive PR screenshots are just marketing collateral designed to cause that fear of missing out aspect. So, for intermediate developers who feel like they are falling behind because they aren't shipping 55 PRs a day, what is the real world metric they should be focusing on instead?
It's a good question, man. I don't know that I have a generic. I'm not even sure there is a general metric that everybody would benefit from focusing on. Or maybe this is going to be a very high level one, right? Amount of time wasted, minimum amount of time wasted. So like if you're spending 6 hours a day on Instagram, don't do that. Like the world is changing fast. There is a lot of things happening, and the ability that you have to stay focused, to invest your hours productively, is going to be what sets you apart in the long term. It's not going to make a difference today. It's not going to make a difference tomorrow, but it's going to make a difference in years. Years of compounding, of effort compounding on itself. You wasting less time than everybody else. And let's be real, you're going to waste some time, right? But don't waste a lot. Waste less time. Try to minimize the amount of time that you waste. Only, and maybe try to fuse the time that you waste with recovery time. So try to manage your time better and invest effort into learning, into bettering yourself. Don't be lazy. Those are the things that I think the general advice that I can give. I don't think that there's any specific topic, any specific thing that anybody should be studying. It's just about, because when you invest effort, you discover your own niche, you discover your own flavor of being a good engineer. Some people are going to be focused more on UX, some people are going to be focused more on database performance, some people are going to be focused more on formal methods. Some are going to be focused on high performance in memory computing, like HPC, like multi-threading, parallelism, all that stuff. So you're going to discover your own recipe by investing effort, by not wasting time.
Yeah, that makes sense. And you recently switched your workflow away from Claude Code, saying that it is not that efficient. And you move to OpenCode paired with GPT 5.5 using CMux to group your tabs.
Yeah.
If you can walk us through your secret PR strategy and why having a clean visual interface to inspect AI diffs matters more than letting an agent autonomously run wild in your code base.
Yeah. So that, I'm not going to say that that's the case in every context. I think that there's many contexts in which just letting the agent run and having a robust enough verification can work. It's when you're shipping prototypes, you're shipping internal CLI tools, stuff like that works. When it comes to shipping features for a large, complex distributed system that other people are going to have to maintain and other agents are going to have to maintain, it's very important not to have one feature be 10 times the lines of code that it should be, you know? And it's very important to not bottleneck your team and not waste your teammates' time by letting them see the first piece of garbage law that you yeet out into, right? So that's what the secret PR strategy is for. I build a plan. So I iterate with the agent and then build a plan. And then I have the agent implement this very large, complex feature. And then I need to look at the code. I need to look and see what it did. A lot of times the agent, so some of the common mistakes that the agents make in Rust is they'll give you these return types that are super, super complex. So it'll be like a result of a tuple of like 4 things. And that's not right. Like nobody can read that. Agents do an okay job at reading that, but then humans trying to follow what the code does, they can't read that. So that's a thing that you have to see. Like you don't let a teammate give you that feedback, because it's very obvious feedback that everybody's going to give you. And if you're well aligned with your coding preferences with your team, don't let them see you break those coding preferences. The agent is going to break them. You catch it, you know, and then you have that's what I do. Like I issue out the secret PR, and then I go taking notes, and I put it like in a little the notes, the Apple Notes app, and I just say, 1, change the return type of this function to this other thing. Change the input type of this other function to this interface, and I design the interface myself. Change the name of this, change the name of that. So I have like 20 notes, and then I give it to the agent and say, hey, look, fix all these things, make sure the tests run, and then update the pull request. And then that way, when somebody sees it for the first time, they don't have to, it's actually a readable PR, and they don't have to invest mental bandwidth untangling unreadable types, and I don't waste their time. It's very, very important with AI to not waste other people's time. Like don't put garbage slop on their desk that you obviously didn't read, because that's just not kind. As that you're not a good teammate if you do that. You know, you're having other people, you're expecting other people to absorb part of what you're going to get credited for, part of what it should be your work. So yeah, don't do that. And that's my main thing, my main reason to work the way that I work. But yeah, like at work, I use Kiro CLI, and Kiro CLI doesn't have a clean diff inspector UI, but OpenCode does. So with OpenCode, when I'm working on like personal projects and stuff, I used to like personal projects are just for me, and I used to still send a pull request to GitHub to inspect the diff, because it was the nicer way to do it. Like I liked it better than doing it in with the Git diff locally. But now with OpenCode, I can just I don't even have to send the PR. Like after it's done, OpenCode is really designed for developers. It's really designed for people who understand how to truly use AI. Cloud Code is designed with the premise of we're going to replace developers, and you're not going to ever see the code. And it's designed like it's designed unrealistically. So it's just the constraints and the philosophy that they have. It's just not good for me, because I don't believe that. And I don't believe that you know, Cloud Code can keep you from ever having to look at any code.
Got it. You also shared a great story about runbooks. I mean, which is the documents team use to fix recurring bugs. You used to kind of hate them because they accumulate until search can't parse them. But you realized you were wrong about it, because vector databases and RAG completely solved that data clutter. So, according to you, what did that experience teach you about when to fight an architectural battle?
Yeah. So the first time I joined AWS, because I joined for 2 years, left, and then came back, and I've been here for 4 years. The first time I joined AWS, I joined into a pretty mature team, and they had a wall of runbooks. They had like 300 runbooks, and nobody ever read them, and nobody updated them. They were all out of date. I mean, anytime like me as a new guy into the team, I would actually go and spend 30 minutes finding the right runbook, go into it, and it was out of date, and it didn't work. And it was like, oh my God, it was so frustrating. So that's where I kind of developed that feeling that, hey, let's not have a wall of runbooks. And then this team is new. So when I rejoined AWS, I rejoined to Verify Permissions team, and I helped launch the product. So we were accumulating runbooks little by little. And now we've gotten to the point where we have a wall of Rumbles. We have like 100, and people are actually. We had an incident last week, and I had written the run book for it, so I knew where it was. But like the on call person didn't know about it, and they didn't find it. They weren't able to identify it in the wall of run books. So then that's when I started realizing, man, like, okay, it's happening again. I was right. But then I thought a little bit more about it, and I was like, well, was I right? Because I could grab the URL and forget RAG and vector databases. That's just an optimization, right? You could grab the URL because we have a root URL for all the runbooks, for the list of runbooks, and just paste it and tell the agent, hey, look, crawl this URL and find me the runbook about such and such. And it'll do it. It'll take like a couple of minutes, but it'll do it. And I tried several different runbooks and it worked. Like, it didn't fail at a single one. So I think that problem is solved. And I'm glad that I didn't burn, political capital trying to fight against the managers that wanted to have the run books, because they were right in the end. Like, it turns out that circumstances changed and they were right in the end. And so the main thing is that you have to, whenever you think that there's a problem coming, don't pick a fight over it. Pick a fight over it when the problem comes, and don't really pick a fight over it. Present a solution, right? Start thinking about what a solution is. Just propose an alternative. That's the other reason why I didn't really try too hard to fight us creating more and more runbooks, because okay, what's my alternative? What's my better alternative? Just not doing it, just not writing anything. This is not an alternative that's going to be popular with people, and that's going to be easy to sell. I might be okay with, hey, look, for the things that I'm the specialist on, just pay me if you need help. But a lot of the rest of the team might not be okay with that. And getting everybody to agree to that would be a very difficult thing to do, and not worth even trying. So that's why I didn't try to fight that fight. And it turns out that I would have been wrong anyway. And the runbooks were a good investment.
Right. Yeah. And one Medium article that you wrote that uses the theory of constraints to explain why development teams aren't actually delivering more software despite using AI, which is a very common problem. So if AI makes the literal typing of code 10 times faster, where is the actual bottleneck shifting to in an enterprise engineering pipeline?
Yeah, I mean, there's several bottlenecks. The bigger the pipeline, like in AWS, as you know, we have all these regions. Each region is a production deployment. So we have, I don't know, 37 production deployments, something like that. It's not very common. Like most companies just have one production deployment. But in the case of AWS, you have your users split all across the world, and then until a deployment goes through the entire pipeline, you may not have uncovered everything that you're gonna uncover in production. We recently had a thing that happened where there was just one customer that had a usage pattern that triggered a bug, and then we released a change, and the change got held up in the pipeline, and it didn't reach that customer's production region for like a month. So it's a month-old change, and we're finding the bug now. So that was a hell of a problem. But what I'm trying to get at is that AWS has constraints that most businesses don't have. I think that there are two primary bottlenecks that do apply to both systems, most businesses. One of them is your staging and QA environment. So you deploy the staging first, and then you run some integration tests there. Hopefully you have some synthetic traffic as well, because you integration tests, you run them once, right? But with synthetic traffic, you have this old thing, like this old account that's just running queries. Like it's like pretending to use your app over and over. And that, having those old accounts that come from an old database schema, that can reveal a bunch of bugs. The integration test create a new account, they do changes against it, and then delete the account. Typically, integration tests typically get cleaned up like that. Synthetic traffic typically is like old, and so hopefully you have both. And then everything passes, and then you merge to production, and then that's the second bottleneck. Because in production, depending on the quality of your staging verification, in production, you might have a big universe of potential bugs that you can discover. If you have a lot of what I call input space coverage in staging, because it's not about line coverage. You can cover lines of code. You can cover 100% of lines of code and not cover all the inputs. that could potentially cause your system to have a problem. So if you have a lot of input space coverage in your staging workflows, what that accomplishes is reducing the percentage of bugs that you're going to find in production and increasing the percentage of bugs that you're going to find in staging. So like your defect rate is what it is. It depends on your programmer skill, the state of your code base, a bunch of other factors like that. But let's say that your defect rate is 5%. What your staging verification checks do is they discover some of that 5%. How much depends on how good they are. In many cases, people just have like these little smoke tests and they discover like 10% of their production defects. So if you have a 5% defect rate in staging, you might discover 0.5% defects. 0.5% of deployments might be buggy, like might find a bug in staging. And so the higher that goes, the better it is because you don't ship bugs to production, but the more staging then becomes a bottleneck. Because you deploy stuff and then the release can't make it out. Like there might be 5 people working on different things, and one developer ships a bug to staging, and then that release can't make it out to production because that thing in staging is failing. So that the better you get at detecting bugs, the more staging becomes a bottleneck. And also, the more complex your systems are, and this is a thing that applies to many enterprises, you have a bunch of separate systems. You have one backend for billing, one backend for this, one front end for that, one front end for that, and they all have to work together. And a lot of times you're making a change that cuts across all of them. And there's the efforts to get them all running locally and test locally is like a week of work. So what people do in practice is they just end up shipping. Ship it to staging and test it there, because in there, everything's integrated the way that it's going to be in production. And then you go and test it. Oh my God, it's a bug, right? So now you've held up everybody else's releases in staging because you have that bug. So that's the other bottleneck, is that people, the more complex the system gets, the more the defect rate into staging climbs, or the more the defect rate overall climbs, because people can't test their code locally. So that's another thing that you have to work on, is your ability to, how many defects can you find before the code leaves the dev's computer into CI? Like that's the ideal state to be in. Like you should be able to run absolutely everything end to end and run tests for everything end to end in CI, because in CI everything is parallel. So every developer has their own, CI workflows running in parallel. And then when they merge to main for it to go into staging, that, or whatever branch you use for staging, that's when you hit the first bottleneck.
Got it. Okay. My next set of questions, I mean, I won't take much time. It's already over. Just 5 more minutes.
Sure.
Yeah, my next question is on AI agents. Like when an AI agent spits out a massive block of functional code in seconds, it drastically increases the cognitive load on the senior engineer who has to review it. So are companies just trading a writing bottleneck for a code review or a testing bottleneck that humans can't scale past?
Yeah, I mean, I think some of that is definitely happening. It gets worse the less attention the driver of the AI pays to the code. PRs are certainly getting very big, and they're very difficult to review. And yeah, I mean, that's a problem that I haven't yet figured out how to address. But yeah, it's happening for sure. I think it's happening to a larger degree. It's worse in some places than in others. In some places, they just basically said, and there's 2 variables that go into making it worse. Number one is the level of cognitive surrender, so to speak, is of the person issuing the PR. So how little they pay attention to the PR and offload that responsibility to the senior engineer. That's one factor that makes it worse. And then the other factor that makes it worse is just how ambitious the roadmaps are, and yeah, how much pressure there is to deliver more of the same things, and just generally how much pressure there is to deliver more with AI. I think that a lot of organizations are suffering from that. There's just like a lot of top-down pressure. We should be delivering more. We should be delivering more. Why aren't we delivering more? And that just translates into the individual engineers cutting corners, and then the senior
Mhm.
engineers looking at these massive PRs and then just kind of like, doing my best. Maybe I'll run it through AI myself and say ship it. I don't really understand it, but let's go. Let's run the risk. And that just manifests as defects later and slow down later.
Right. Yeah. Uh, my next question, last question is on the knowledge gaps. So, I mean, you are very passionate about helping engineers maximize their earnings and impact. Uh, According to you, as AI tools commoditize syntax and basic scripting, what specific non-coding skills will differentiate a staff level engineer pulling in top tier total compensation from someone who is easily replaced by a harness?
Yeah, I mean, I think that being a specialist in certain things used to be an answer to that. So like you're just the best at database performance. You're the
Mhm.
best at high performance computing. I think that's still very useful. Foundational knowledge is still very useful, but I think it's a little bit less important. I think it used to be on equal footing with just product mindset. And I think product mindset is going to be more important now. The ability to connect what customers need to what the business needs and to be strategic about how you implement features to tackle. Maybe there's 5 different customer asks that if you tackle them individually, they result in 5 different complex features. Or if you tackle them as one, to give you an example, let's say that in my system, verified permissions, you create policies based on, it's like IAM, but for your application. So the first thing you have to do is define a schema where you say, hey, my application has email campaigns and SMS campaigns and users. You define the types of things that exist in your application and the types of actions that can be taken. Because in IAM has things like EC2 instances, S3 buckets, and the API calls that you can make. It has all of those hard coded into it. IAM is designed for AWS, but your application doesn't. Users don't interact with S3 buckets or EC2 instances or anything like that. They interact with reports and other users and organizations and so on. So you create all those entities as a schema and you start writing policies against them. And sometimes you change your schema and that might break your policies, but you might have a million policies. So it's not a check that we can do synchronously, right? So a
Mhm.
lot of customers ask us, hey, look, can you help us revalidate our policies when we change our schema? And that's a thing that we haven't worked on yet. But you could conceive of that as just a general workflow, and then that workflow can be used for a lot of different things, enabling encryption in the policy store, enabling multi-region replication in the policy store. You have to basically, the workflow is one that goes and downloads every record in the policy store and does something to it. So the
Yeah.
generic engine that's going to be, so if you think about enabling multi-region replication, enabling encryption, and revalidating, they're all as separate features. You build 3 different hard-coded workflow engines, right? But if you think of them holistically as a single feature, you're going to build one workflow engine that's capable of doing 3 things. You're going to have way less code and
Yeah.
be able to meet the customer needs faster. So that's what I think, like that strategic mindset, engineering strategy meets product strategy. I think that's what's going to make people more valuable.
Makes a lot of sense. I mean, these were the questions, Victor. Thank you so much for answering all of them. Before we stop the recording, do you have anything for me for now?
Um, yeah, I mean, I just want to encourage people to stay curious, keep learning, and don't succumb to all the fear mongering and like all the stuff about, hey, AI is going to replace us and the world is going to end. And like, dude, like the world has a long history. And if you really think about it with a sober mindset, you'll realize that even though there's been a tremendous amount of technological change, people haven't changed that much. People have been the same way always. There's always been a lot of greed. There's always been a lot of exploitation. It's not going to get better, but it's also not going to get that much worse, you know?
Yeah,
So be optimistic, just work hard and do your best and things will be fine.
that's lovely. Thank you so much for that. Before we leave, I would just like to thank you for the time. And other than that, it was great talking to you. I would like to stay in touch on LinkedIn.
For sure.
And yeah, thank you so much and all the very best for your future endeavors.
Thank you. Likewise, Akash.
All right. Thank you. Bye for now. You have a lovely day.